Okay, so today we're going to be learning about Newton's method, and Newton's method is basically another way to approximate zeros. Now, this method is actually pretty easy, and all you have to do is first, we're going to give you a function. So for example, y equals x to the fifth minus 2x cubed plus x minus 4. Okay. Now the second step is to find the derivative of this, which is y prime equals 5x to the fourth minus 6x squared plus 1. Now what we're going to want to do is we're going to want to graph the function and to kind of see where the zero looks like it's around. So for example, if we were to have this and it were to give us about 1 and 2 on the x-axis, it would cross through about right here. So we're going to start off with about 1.8. Now you're going to have to make a table. So we have n, xn, f of xn, f prime xn, f of xn over f prime xn, xn minus f xn all over f prime xn, or just over. Okay. Now we're gonna have it wants us to go to 2 iterations. So that means we're gonna stop right here at 2. Now we're gonna start with our estimate, which is 1.8. Now we're gonna plug 1.8 back into the function and we get 5.03168. And then we're gonna plug that same value into the derivative, and we're going to get 34.048. We're going to put that over that value and get 0.147782. Then we're going to do 1.8 minus this value and get 1.65222. Okay, now we're going to use this value and we're going to plug it back. We're going to put it right here under 1.8. That's going to be our second kind of testing point. So we have 1.65222, plug it into the function, 0.94392, plug it into the derivative, and we get 21.8809. And then we have the function over the derivative, and we're going to get 0.043139, and then we're going to do this value minus this value. We're going to get 1.60908. And your answer, your x value, is going to equal this second iteration, which is 1.60908. Now, once you have that, we can actually approximate I believe it's the tangent line. We can do the tangent line approximation. So you have tangent line approximation from this value. Now, the tangent line, it's going to be the tangent line at BC and then f of c. So how we do this, so we have y equals f of c plus f of c, f prime c times x minus c. Okay. So we have f of c, which is actually this number. So that's your c value. So we have 5.03168 plus f prime c, 34.048 times x minus c, which is 1.8, equals y. And when you just calculate all of that, you're going to get a value. So you can just simplify it like this. Minus the product of this. And that is also your tangent line approximation. And to see if you have this and you wanted to go a little further, you can find the actual change in y. Which is basically very simple. It's like the same thing, but you have a different formula. So you have change in y equals f of c plus delta x minus f of c. And you just plug everything kind of back in. But yeah, we need some other values, but those are differentiations. So that's kind of a whole nother topic, but this is Newton's method right here. Pretty simple. The calculator needed for this one with these big numbers, and that's it. Goodbye.